Welcome back, my 43 subscribers. So, I've been out of town for quite a bit. Before I left, I was able to get the axles, rear truss, and everything welded in and dropped off the powder coat, and I just got it back. And thinking about tonight, about what steps I want to do and get out of the way. But today was just more or less getting everything here, cleaning up the shop and getting ready to do the reinstall for the differential and all the bearings and all the fun stuff. But I wanted to show everybody how it turned out. I didn't really do any videos of me building it because I was in such a time crunch and I had to get it done before I left for work. I work out of town, so unfortunately sometimes I rush through these projects and don't get to film it or capture it. But this is how it turned out. It turned out pretty darn good. Now, the truss was an Artec truss. There's actually three pieces that I bought. There was this part, and then obviously the other side, and then the top piece were all three separate pieces. And then I basically chopped and modified the entire truss to fit my axle and what I was trying to do with it. Now, you might wonder why I didn't do something here. And it's pretty simple. I just ran out of time and energy to actually kind of do something with this part, and I really didn't want to modify the spring perch at all, so I just kind of left it alone. You can probably wonder and say that this piece right here is kind of useless, and I would probably agree with you, but what I did was I tapped a bunch of holes every so often for some other pieces and other things, so I'm thinking that maybe I'll put a limiting strap from this point to the frame, or maybe just do nothing at all. But I put it in there anyway, just for the hell of it. It looks pretty darn cool, but it's probably not doing anything. And so when you buy the Artec truss, obviously it's not going to look like this, and I actually had to build these pieces on my plasma cutter. Originally, they were built out of 1/4 inch plate steel, and then I recut them out of 3/8 plate steel. And basically, yeah, that's how I got those pieces. I cut them out myself and then kind of fit everything customly. So, unfortunately, you would not be able to buy this setup from Artec. You'd have to build it yourself, or buy the pieces and then do it the way I did, which it takes quite a bit. I think, if I can remember, I probably have about 7 days of fab and welding into this whole rear truss. You can probably do it quicker if you know what you're doing, but I was doing it kind of like testing it, fitting it, trying it, seeing if everything lined up. I didn't really know what the direction was at first, so I was kind of happy when I finally started getting it sort of closer to the completion step and seeing how it was going to turn out. But it was a crap load of work to get this all looking proper. Now, almost every piece over here had to be cut. There's nothing that fit in perfectly. Even the top truss was actually ripped down the middle and then shortened, which you can't tell because I did a really good job of chamfering the weld and then filling it in and then re-grinding it flush so that you couldn't tell that it was spliced together. But take my word for it, that thing is solid as can be. There is no fracture line or crack line that I can follow from the bottom side. It's perfect. I checked. And then obviously there's a lot of cast welding on the back side. I mean, in the front side too, but a lot of cast welding you got to do on these, and the cast welding wire is fucking expensive. A lot of people don't do a lot of the welding on the cast because it's just kind of intimidating for them. It's really fucking easy if you have the right wire and a proper welder, and you do all the proper prep steps in order to get the metal prepared for welding. It goes really, really, really simple. You can tell, I mean, you can look at the welds on here. I don't know if you can see properly. There we go. The welds look, you wouldn't be able to tell really if these welds are any different than, let's say, these welds, which these are all mild steel welds, and then these are the royal purple cast to mild steel welds. So it's a different wire. It does weld differently, by the way, so don't think it's the same. It's just, it takes a little bit more patience and prep time to get that stuff to look right. And what's kind of annoying about welding the cast is, like, let's say you stop halfway through your weld and then you want to restart. You can tell when you start and stop with this cast welding. There's no way to blend it nicely. You can kind of tell, like right here, for example, where I went, stopped, and then continued over. There's no way to blend that nicely. That doesn't really matter, but I'm just letting you guys know that if you go to do a welding onto a cast piece, try to really plan out how long and where your start stop points are going to be, and try to hide it all if you can, and also wrap your corners if you can. So anyway, you can tell that got a hole there, 2 holes there, 1 in the center, same thing, 2 there, and then 1 there. The idea behind these 2 holes are, I didn't know where my spacing was for my airbag plate, so I just kind of put 2 holes there, kind of give myself a little bit of wiggle room. I think the first hole's right, meaning that hole's right, and I just put that one there just in case. I can always modify stuff later, but I wanted to get the holes cut in prior to powder coating. So, and you can see why, because I had built this hook that screws into the center, and then you can follow my gantry up. There you go. So that's how I'm going to be able to manipulate the axle when I'm working on it, so I can get the diff plopped in and keep the paint all nice and stuff like that. So it came out excellent. So a couple things I wanted to point out, which are not very important, but there's some stuff that you might want to think about if you're going to be doing a project like this, which is they want you to fill your differential through that hole right there, which is on the back side of the case. Now, if you can imagine, your axle is going to be under your truck, and they're expecting you to put gear oil into that port on the side of your case. There is no way to get this, you can't put your bottle through here and into that hole. You got to come from the side. And obviously you can get a hose and a funnel and then snake it up and around. But I don't know if any of you ever worked with gear oil before, but gear oil is about as thick as honey, and you cannot push that out of the bottle and without blowing something up. I mean, like, you can push so hard you'll push the cap right off the bottle, and that oil will basically not even move. It does help to get the oil warm before trying to dump it into your case, but I had thought about this ahead of time, and I had already anticipated that I was going to be filling this up, and it was going to be a pain, and I didn't like the fill port on the rear axle, so I went ahead and added in this auxiliary fill port / breather port for the differential. And you can basically, get your tool in from the top down, and then put you want to put a plug there or an air fitting or whatever it is you want to put there. It's available, and it'd be a really easy spot to fill up your differential. There's no reason to make it harder. I lied. It was a little bit difficult to put this piece into here. You can see, how can I explain how I did this? So, okay, how I did this was I took my mag drill and I put it on top here. The first hole I drilled was the diameter of the hole with the threads. So I plunged in straight and kept going, bored through the case, and then I had this hole right here unthreaded. And then after that, I'll take that back. I welded the piece in first. It was a piece of pipe that I cut in half, welded it in, and I bored it down, right? So the first hole I drilled was that threaded hole, and then I left it unthreaded. And the second operation was I switched out. I didn't move the mag drill. Just swapped out the bit for the larger. I think it's like a 21 millimeter hole. I don't know, but I swapped the bit out, and then I plunged into it, and then I reamed the hole out so it's a nice, perfect diameter. Obviously, there was weld buildup over there, but as I reamed it or / bored it with the mag drill bit, it cleaned up those edges real nice. And then I plunged it down and recessed it in a little bit. I added a little spigot right here. I guess we'd call it a spigot, or what's it called, a gutter. So if any water gets in there, it can then drain out the case and not pool on that spot. And then at the very end, I just came through with what is it, like a 1/2x13 or something tap. And no, I lied again. It's a 1/4-inch MPT thread. That's what I put there. So a 1/4-inch MPT thread, I tapped it in there. So you can put a breather or a plug or whatever you want to put there. Now Ford originally has got one over here on this side of the case for the breather for the axle. I don't really like that spot, but I left it in there just in case. I think what I'm going to do is I'm just going to plug that hole, or I might leave it and just reroute the hose the same way it was originally or something, but I don't know. I don't really understand why they would have put it over here, but I left it there just in case there was a reason. And I added my own, which is, again, a double reason for a fill port and a case breather. And then, other than that, only other thing I can talk about on the axle today is the speed sensor hole, which I probably made a couple videos on this already. I feel like I'm so excited to explain this to everybody, but what it is that's the speed sensor hole. You got to bore that out. It's like a 21 or a 22 millimeter. And it's an M8x125 thread for the threaded hole there. And then you just line it up. You get that case board in there, the whole board in the case, and then the speed sensor just plops right in, and you're good to go. Not really a whole lot to figure out once you get that hole indexed properly. And then, yeah, I mean, that's pretty much the setup. I'm really happy with how well the truss kind of came out. It was kind of a hack job at first, and then it really sort of kind of tied together at the very end. But I put so much time into the prep work and the grinding to get everything looking sharp. And even before I dropped it off for powder coat, I did a lot of just final steps just to give it a little bit better of a finish on it. But at some point you have to call it in and say, okay, this is good enough. It's going to be under the truck. Nobody's ever going to see it. Who cares? But it was a fun project. I really think it's going to look good. It's going to match the front of the axle very well, I think. So I got a couple more things I got to do this week before I can get this axle reassembled. So just to give you an order of operations, I got to get the pinion bearings pressed on and then get the pinion loaded back in the axle case. Then I have to crunch down the crush sleeve and get the pinions preload figured out, and then I got to shim the carrier. And then after that, I got to install the seals and the hubs and the bearings, and I should be able to slap this back in the truck, and there should be not a whole lot more to talk about on the rear axle. It's damn near done. And if anybody is curious, I think I've mentioned it in the prior videos, but this axle is actually from a 2016 6.2 liter F250 gas motor. It's still a Super Duty axle. It's a Sterling 10.5 by default, but the reason why you're going to want to go with the gas motor if you're doing it on an older truck is because the gearing on the gas motors is a 373, which is exactly the same gearing ratio as my 03 Power Stroke 6 liter. So I didn't have to buy a new gear set or anything. It came with the right gears automatically. And the other cool part about this axle, which I promise this is the last little piece of information for the video, is because it was a 2016 modern axle. When I say modern, meaning that it was updated by Ford. This one came with an electronic locking diff, which I sold the e-diff on the marketplace, but I'm putting an air locking diff in here. So all I did was I built this little plate, and I bolted it in to the e-locking spot, and I threaded the hole for the air fitting. And basically this little, I guess we could call it like an adapter / conversion plate, converted the e-locker wire loom into made out of steel, obviously, it's powder coated now, but it just basically allows me to remove this piece with the air fitting, and remove it, and just like how Ford would have originally wanted you to remove the e-locker harness. So it kind of worked out. I didn't have to put any extra holes or anything for the airline. I was just basically using the existing port that Ford had drilled in for the e-locker. So really simple. And you might want to know how I build it. I think there's a piece of pipe. I want to say it's about 5/8 diameter, and I welded it to this piece. I built this piece with my plasma cutter, and then all I did was 1/4" MPT tap this piece, and then yeah, it looks pretty darn good. Actually, I can't say I'm disappointed with that. I made it one night late. I was a little bit tired. I was unhappy with the way it looked originally, but I left it alone long enough that I came back and I liked it. But other than that, I am going to end this video, and I hope anybody who is watching enjoys what I'm doing here. Hopefully you'll come back and check out the other videos I'm going to release, but I got a bunch more parts that are powder coated and ready for install. I really hope that everybody sticks around for the next videos, because it's going to start coming together. It's going to be a lot less of me talking about how I did it and a lot more of me doing it. You know what I mean? Great. Have a nice night.